Okay, finally with this concept we have exponential equations. So before we get started, we're going to do a warm-up. Use a common base to solve an exponential equation. So here's how you can solve these, all right? If you have no logarithms, but you have an exponent, you want to find a common base. So 5 is my base here. Okay, 5 is a prime number, so you want to try and get your base to be a prime number, all right? So 5 to the n plus 10. Is there any way I can have 25 turn into a base of 5? And yes, there is. 25 is in fact 5 squared. So I'm going to say this guy is still the same. This is 5 squared. That's what I mean when you find the same base. Find some exponent that you can make the base the same. So now, this is exactly like the log equals log equation. Since my bases are the same, I can set my exponents the same. And then I solve. So minus 10 n equals negative 8. So let's put a little mark here. If bases are the same, then exponents are the same. I'm abbreviating here, but you know what I mean. Bases are the same, then exponents are the same. Okay? This is not a prime number. I can make this a prime number. 9 is 3 squared. This is still a plus 2. 27 is 3 cubed. 4a minus 2. So this requires a lot of knowledge of squares and cubes and how can I make this number this number. Okay, so now my bases are the same. Now I can set my exponents the same. So this is actually all in the exponents. So I have 2 times a plus 2 equals 3 times 4a minus 2. So 2a plus 4 equals 12a minus 6. I'm going to add 6 and subtract 2, so I get 10 equals 10a divided by 10, a equals 1. Okay, so that's how you solve exponential equations with the same base.